planet is made up of complex natural systems that ensure we have the right mix of temperature, wind, water, and oxygen to ensure life on Earth is perfect for humanity's survival. One of these important natural systems is the Gulf Stream, which is a complex ocean current system that affects the weather patterns across the entire world and ensures the stability of temperature across multiple regions. But it appears this system is finally taking a dive as scientists give a terrifying warning that the Gulf Stream is finally collapsing. Have you ever wondered how air currents influence the temperature and distribution of heat across our planet? Well, all these factors are greatly influenced by the Gulf Stream, which is a dynamic ocean current flow that combines multiple drift systems across the Atlantic. The Gulf Stream is essentially a warm Atlantic Ocean current that originates from the Gulf of Mexico, pushing its way up the eastern shores of the United States, up to Canada, and then across the Atlantic to northwestern Europe. The Gulf Stream is an important climatic ocean current that is greatly influenced by processes of western intensification. West intensifications are simply boundary currents, but are greatly influenced by the presence of a coastline, which, in the case of the Gulf Stream, is the eastern coastline of North America. These boundary currents greatly influence the orientation of the Gulf Stream, essentially causing it to be an upward current stream, moving wind and water from the Gulf of Mexico upwards towards North America. Upon reaching a latitude of 40 degrees north and 30 degrees west, the Gulf Stream splits into two, with the southern stream known as the Canary Current veering off to Western Africa, and the northern stream, otherwise called the North Atlantic Drift, crossing over to northwestern Europe. The Gulf Stream is a dynamic and complex current flow system. It is essentially a river of seawater that is mostly wind-driven and maintains a pre-existing path that has basically been the same for thousands of years. Looking at the flow and movement of the Gulf Stream, one can easily deduce that it moves like an invisible conveyor belt, carrying a varying range of sea currents with warm temperatures to much colder parts of the planet near the Arctic. These currents then make a U-turn upon reaching North Europe and West Africa, and with trade winds in the tropics blowing them west, returning to the Gulf of Mexico. This combination of multiple ocean wind currents makes the Gulf Stream one of the strongest ocean currents in the world. The Gulf Stream is able to transport obscenely large amounts of water at a rate of over 30 million cubic meters per second. The accelerated movement of the Gulf Stream increases as it reaches the coast of Newfoundland in Canada, where the volume of water increases to the rate of 150 million cubic meters of water per second. This makes the volume of the Gulf Stream much higher than all the rivers that empty into the Atlantic combined, at a meager rate of less than 1 million cubic meters per second. Looking at a map of the Gulf Stream, one might think it's a relatively small stretch of sea current, but in reality the Gulf Stream stretches over 100 kilometers wide and can reach depths of 1,200 meters below the sea surface. The current velocity of the Gulf Stream is commonly around 2.5 meters per second and is fastest near the sea surface. As the water is transported at such high speeds, the sea surface undergoes evaporative cooling, which intensifies as the warm water moves further north. This process of cooling is important to the distribution of temperature across the multiple regions the Gulf Stream flows through. As the water cools along its path, it results in an increase in density and salinity. This results in a separation of salts when sea ice forms, a common Arctic process known as brine exclusion. These processes result in water that is colder and much more dense, so much so that this dense water begins to sink down through the less salty and less dense waters of the North Atlantic. This denser, colder water sinks well below 1,200 meters, falling out of reach of the Gulf Stream and effectively becoming a part of the North Atlantic Sea. While the Gulf Stream plays a big role in pushing water currents for the Gulf of Mexico all the way to Europe, it has a much greater effect on weather patterns in these regions as well. The sheer force with which the Gulf Stream flows, in addition to its proximity to beaches along the long stretch of the eastern coastline of the United States, makes it a powerful system in determining weather patterns. The stream is also responsible for instigating changes in sea levels, which in turn has a great effect on tides and coastal erosion. But that's not all. The Gulf Stream plays a major influence on the climate of these coastal areas of the United States, most especially the Florida Peninsula. With the Florida Peninsula extended outward into the Atlantic, it puts this long stretch of coastline under the direct influence of these warm water winds. During winter months, most parts of the United States see a drop in temperature to well below 20 degrees Celsius, except Florida. Thanks to the Gulf Stream, the Florida Peninsula is able to maintain temperatures of at least 24 degrees Celsius in winter months. East winds from the Atlantic also aid this temperature halt by blowing over the warm waters of the Gulf Stream, carrying warm air inland and aiding in keeping temperatures warmer compared to other parts of the United States in the cold winter months. The Gulf Stream also helps in maintaining the biodiversity of the regions like Nantucket, which happens to also be well within the range of these warm air winds. Further north, the Gulf Stream affects the climate of Northwest Europe in the most dynamic ways. It has been established that although most of Europe is extremely cold due to its proximity to the Arctic, most coastal parts of Northwest Europe are relatively warmer than the rest of Europe. The North Atlantic current of the Gulf Stream, which is the current that bifurcates towards Northwest Europe, is known to carry warm air all the way from the Gulf of Mexico to that part of the world. This transatlantic movement of warm winds enables coastal parts of countries like Ireland, the west coast of Great Britain, and other Western European countries to stay a few degrees warmer than countries to the east of the continent. However, the warm winds from the Gulf Stream are most highly felt on the western coastal islands of Scotland and Norway. Although most parts of Norway are covered in snow and ice due to their proximity to the Arctic zone, most of Norway's east and western coast remain free of snow and ice for most part of the year. This significant warming effect has enabled a much larger settlements to develop on the coast of northern Norway in big cities such as Tromsø. This western drift of warm air produced by the Gulf Stream has also influenced the warm climate behind the high Scandinavian mountains. But while the Gulf Stream has produced a significant warming effect in Western Europe, which has benefited the inhabitants in those areas, it has a much more destructive effect on the tropical coastlines lining the United States. The Gulf Stream is one of the major contributors to the development of strong cyclones, both within the ocean and in the atmosphere. The contrast of temperature and warm water along the edge of the Gulf Stream has been studied and found to increase the intensity of developing cyclones. The Gulf Stream is one of the major contributors to tropical cyclogenesis, as it is known to produce warm sea winds and increases significant convection in favorable conditions that result in powerful cyclones. Tropical cyclones are commonly formed when water temperatures are in excess of 26.5 degrees Celsius, which happens to be the mean temperature of the Gulf Stream, particularly during the month of July, otherwise known as cyclone season. Storms that originate in the Caribbean and find their way into the Gulf Stream are then pushed in a western direction along the eastern coast of the United States. These storms have been studied to have the potential for extensively strong winds that are known to damage coastal areas in the eastern coastline of the United States. A recent example of a powerful cyclone created by the Gulf Stream was Hurricane Sandy, which ravaged the eastern coastline of the United States in 2012. Hurricane Sandy was a Category 3 storm that originated in the Atlantic but gained significant strength as it passed over the Gulf Stream. To date, Superstorm Sandy holds the record for the largest Atlantic hurricane measured by diameter, with an impressive tropical storm force wind of over 1,150 miles across. Hurricane Sandy cost nearly $70 billion in infrastructural damage and claimed over 200 lives across 8 different countries, from the south of the Caribbean up to the north of Canada. The Gulf Stream has also been found to be one of the major contributors to the formation of strong extratropical cyclones, which are known to depend significantly across coastal areas following the force of the Gulf Stream. Between 1951 and the year 2004, over 75% of extratropical cyclones documented have been found to originate near the warm water currents of the Gulf Stream, with annual peaks during the months of October and May. The Gulf Stream has also been found to generate and maintain powerful cyclones on the ocean itself, maintaining powerful cyclonic systems that extend as deep as 11,000 feet beneath the ocean surface, influencing much of the underwater ecosystem. But despite the wide range of influence, both destructive and otherwise, produced by the Gulf Stream, scientists have observed that the intensity and tenacity of this ocean current system has significantly reduced over the last 50 years. In recent years, scientists have observed that the Gulf Stream may be veering towards irreversible collapse as a result of changing surface temperatures on the planet. Published reports from several scientists and oceanographers have stated that the weakened state of the Gulf Stream could result in catastrophic effects, some of which may be permanent and would affect much of the northern hemisphere. The Gulf Stream is a major part of the Atlantic Meridional Overturning Circulation, or AMOC. This system is a combination of all the diverse oceanic currents that are responsible for regulating a large part of the planet's climate, with major effects on surface temperatures and weather formation. Scientists studying the Gulf Stream as part of this system have observed that it has undergone a significant loss of stability over the last century. As most scientists would explain, the Gulf Stream works more like a conveyor belt, transporting salty and warm water upwards from the tropics to the colder regions of the north and bringing cold water to the southern parts of the sea floor. The conveyor belt analogy does not completely cover the complexity of the Gulf Stream, but it has indeed been found that the movement of both wind and seawater is at its weakest in more than 1,000 years and may indicate a significant breakdown of the entire Gulf Stream system. Scientists have postulated that a collapse of the Gulf Stream would have a monumental impact on global weather systems, which may result in rising sea levels across the Atlantic and produce colder and more powerful storms across the northern hemisphere. The interruption of the movement of winds would cause intense disruption to the distribution of rain across regions of Africa, South America, and India. This interruption of the rain system could cause disastrous effects on food production and crop growth across these major food-producing regions. The Gulf Stream is largely influenced by temperature changes, and due to the rise in temperature on the planet's surface over the last few decades, it may have a disastrous effect on the strength and intensity of the Gulf Stream, further affecting its influence on several regions of the planet. Analysis of Atlantic ice cores and several other geological records deduce that the Gulf Stream exists in two major states, the first state being a stronger, faster movement of oceanic currents, which the human population has come to rely upon today, and the second state being a much slower and weaker state which has not been on record for thousands of years. It indicates that the weakened state of the Gulf Stream is entirely possible, although it's never happened in recorded history and could have disastrous effects that even scientists may not be fully able to grasp with current technology. Predictions based on a wide variety of analysis state that this weakened state of the Gulf Stream could reach a final tipping point such that it becomes almost irreversible. This would mean major parts of the northern hemisphere that rely on the warm currents and winds produced by the Gulf Stream could be plunged into much colder seasons, completely tipping the current climatic conditions of these regions. But there isn't consensus in the scientific community about the analysis and predictions of the future state of the Gulf Stream. Some scientists disagree that the Gulf Stream will completely collapse and states that the powerful oceanic currents may only weaken to points that can be reversed by lowering carbon emissions, which affect global surface temperatures. Others disagree by stating that with current analysis, the future state of the Gulf Stream is reaching a point of irreversible collapse. The difference between these two varying opinions is crucial, but one thing has been found to be certain. The recent drop in sea surface temperatures and salinity patterns in the Atlantic Ocean have been caused by a rising global surface temperatures, which have greatly contributed to the current instability of the Gulf Stream. This is simply because the circulation of the Gulf Stream is highly dependent on the salinity of seawater flowing from the southern hemisphere all the way to the north. The ability of this southern salt water to condense and sink below the Gulf Stream and displace colder northern waters is crucial to the stability and the flow of currents within the Gulf Stream. The density of ocean water depends greatly upon surface temperatures, which makes a major part of the Gulf Stream as the more salty southern seawater gains latitude, effectively cooling as it makes its way to the north. This rise in the density and temperature of seawater makes up for the continuous movement of the Gulf Stream and maintains its powerful effect on regional temperature and weather patterns. But with the current rise in surface temperatures and an increased inflow of fresh water resulting from melting Arctic ice has resulted in less salty water, which in turn affects the strength at which cool and warmer water is circulated within the Gulf Stream. If this trend of reduced saltwater continues, it threatens to drastically affect the flow of the Gulf Stream, which most scientists have stated that if it reaches a critical point, could become practically irreversible. Most scientists have stated that the rapid effect of rising surface temperatures has been unprecedented and will most likely speed up the timeline of the collapse of the Gulf Stream. But other scientists completely disagree with this impending collapse of the Gulf Stream, stating that although the Gulf Stream remains a powerful determining factor in temperature and weather patterns in the Northern Hemisphere, it is still one of multiple factors that influence these trends. They've stated that the Gulf Stream is only one of the multiple Atlantic currents that affect temperature changes and weather patterns in these regions, and that although its weakened state over the last century is measurable, it does not completely translate to an impending irreversible collapse. They've noted that the Gulf Stream in itself is a factor of several other components around the equator, the Northern Hemisphere, and surrounding current resulting from other basins. Other oceanic currents also greatly influence temperature and weather patterns in these regions, and the Gulf Stream couldn't possibly be the sole determinant in a change in the regional climate even in its weakened state. Temperatures taken from both the northern and southern hemisphere along the lines of the Gulf Stream do not indicate a complete overturning of circulation. This is simply because the Gulf Stream is a much more complex oceanic current and is not a simple conveyor belt factor as most models make it seem. There are several other mathematical factors that play into the intensity of this powerful Atlantic current, and a change in surface temperature, however rapid, couldn't possibly cause irreversible damage to a system that has existed for millions of years. Further analysis from ice cores that have existed for thousands of years indicates that the movement of the Gulf Stream fluctuates not just from month to month, but possibly from century to century, or even varying over thousands of years. This analysis indicates that the current state of the Gulf Stream might simply be a turning point that has reoccurred over thousands of years and may very well self-correct in the coming decades. In essence, the current state of the Gulf Stream may be a direct result of a change in global surface temperature and reduced salinity due to melting Arctic ice, but it doesn't translate to a pending irreversible collapse. In addition, current technology is still unable to fully map and model the complete complex state of the Gulf Stream, which indicates that although scientists have been able to analyze and study it, they are still fully unable to grasp the factors that maintain this Atlantic current. Scientists have stated that efforts should be made to fully understand the complex state of the Gulf Stream before making definitive statements on the future state of this powerful Atlantic current.